Let's talk about the number 23. At a glance, it might seem pretty ordinary, but it's actually hiding a really cool mathematical secret. A secret that lets you figure out some pretty tricky division problems right in your head. Seriously, no calculator needed. Ready to see how it's done? Okay, so let's just dive right in with a challenge. Take a look at this number, 10,007. Could you tell me, right now, if it's perfectly divisible by 23? I mean, it's a bit of a tough one, right? Of course, you could just pull out your phone and punch it into a calculator. But where's the fun in that? We're here to dig into the clever problem solving behind the math. It's not about just memorizing rules, it's about understanding why they work. And honestly, that's way more interesting. So everything we're about to do, and I mean everything, hinges on this one simple piece of arithmetic. 70 equals 3 times 23 plus 1. Now, that might seem totally random, but trust me, that little leftover 1 is the secret key to a really powerful strategy for checking divisibility by 23. And that brings us to what we're going to call the A plus 7b strategy. It's a pretty playful method that uses the very last digit of a number to shrink it down into something much, much easier to work with. Let's try to picture this as a number machine, okay? You feed a big, clunky number into one end, and it spits out a smaller, simpler one at the other. And here's the magic. This new little number has the exact same divisibility by 23 as the big one you started with. So how does this machine actually work? Well, it's a simple, repeatable process. First, you take your number and split it into two parts. B is just the very last digit, and A is, well, everything else. Then you calculate a brand new number by taking A and adding 7 times B. You just keep doing that over and over until you get a number so small you can instantly tell if it's a multiple of 23. Theory is great and all, but let's actually see this thing in action. It's time to put our strategy to the test with a couple of examples. All right, let's start with a fairly simple one. 161. Is it divisible by 23? Let's find out. Let's run it through the machine. Okay, here we go. For the number 161, our last digit, our B, is 1. The rest of the number A is 16, so we just calculate A plus 7 times B, which is 16 plus 7 times 1. And what does that give us? Boom, 23. And since our result, 23, is obviously divisible by 23, it means our original number, 161, has to be as well. You see, the whole point is that the strategy preserves divisibility. Pretty slick, right? All right, that was a good warm-up. But let's try something a little bigger. How about 529? Now, this is where that repeat step really gets to shine. Let's break this one down. For 529, our first go-around gives us 115. That's still a bit big to tell at a glance, right? No problem. We just run it through the machine again. So for 115, our next calculation gets us down to 46. And since we know 46 is just 2 times 23, we know our original number, 529, must be divisible by 23 as well. See how we just keep chipping away at it? Okay, so we've seen that it works, but the bigger, more interesting question is why? I promise you, this isn't magic, it's just really elegant mathematics. So let's pull back the curtain and see what's actually going on under the hood. To really get the why, we need one quick concept, modular arithmetic. Now, it sounds complicated, but it's really not. Saying two numbers are congruent modulo 23 is just a fancy way of saying they have the exact same remainder when you divide them by 23. That's it. So x is congruent to 0 mod 23 is just math speak for x is divisible by 23. And here it is. This is the heart of the entire strategy. Remember that fact from the very beginning? This is just the formal mathematical way of saying it. 70 is congruent to 1 modulo 23. And why is that true? Well, because, as we saw before, 70 minus 1 is 69, and 69 is a perfect multiple of 23. That tiny mathematical fact is what allows us to swap numbers around and create this amazing shortcut. It's the linchpin of the whole operation. Now, this slide shows the formal proof, but here's the key takeaway you need to know. When we multiply our number by 7, it actually doesn't change whether or not it's divisible by 23. And that's because 7 and 23 are what we call relatively prime. But what it does do is cleverly rearrange the equation so we can use that 70 as like one property to create our shortcut. It's like a little bit of mathematical jujitsu. So as we wrap up, it's really important to see this for what it is. This is not some fixed magical rule you have to follow. It's a beautiful example of mathematical problem solving in action.
So let's just recap some key ideas. 23 is a prime number. The number 7 is our secret ingredient because it gets us to 70, which is just one little step away from a multiple of 23. And hey, our test case, 529, turns out that's just 23 squared. The big takeaway here is that these aren't just random rules, they're clever solutions that come directly from the properties of the numbers themselves.
And that leaves us with a bigger question to think about. What other math rules that you learned in school are actually just clever problem solving in disguise? There is a whole world of mathematical beauty out there just waiting for us to explore it. Thanks for joining me.